Okay, so we think of f of x as not f of x, we think of it as y equals, right? So then to find its inverse, what do we do? No, not yet. Switch the x and the y, right? Just the x and the y you switch. Okay, some of you are switching numbers too. Okay? So we rewrite this as x equals 3y minus 4. Nothing else changes. Just swap them. Okay? Some of you, I saw one, it looked like this maybe. It might have been, and instead of swapping the x and y, you just swap the numbers and just flipped it. Okay? So understand what we're doing here. Okay? We're not doing that. Now, like somebody told me, I'm going to take the 4 over, right? You guys know how to solve for a variable. It's our normal solving for x or y, solving for a variable, Do the opposite to move the opposite side, right? So what's the opposite of multiplying by 3? Dividing, right? So if you want to leave it like that, x plus 4 over 3, that's fine. Some people split it up into x over 3 or 1/3 x plus 4/3. Either one's acceptable. If you want to just leave it one fraction like that, that's okay with me. Olivia.
Are you supposed to graph that part?
Again, you don't have to. Okay? I'm not worried about graphing. You guys know how to graph.
Once we get to the class, you can worry about that.
No. Okay. Okay? I don't think I put the graph part. I just say find the inverse. Okay? Any other questions? So that's all we were doing yesterday, right? Just switching or swapping, however you want to say it, x and y, and then getting y by itself. Number 3, it says graph the relation, connect the points, then graph the inverse, identify domain and range of each relation. Okay? Again, domain is what values? X, ranges, y. All you had to do, all I want you to realize is you're just switching them, right? Your x values, your new domain is -1, -2, -4, -4. And your new y's, your new range is 3, 4, 1, -1. Okay? Just switch them. All right? Number 6 would be f inverse is 2 times x when you're done. Number 9, f inverse is 2x minus 6, or you could write 2 times the quantity x minus 3. You don't have to distribute the 2 if you don't want to. Both are correct. Number 12, f inverse is 1/4 x minus 1. You might have had x minus 4 all over 4. That's okay. That's the same thing. Number 15 was, if I can find it, four times quantity x minus 2, or 4x minus 8, if you distributed it. 18 was like number 3 again. If you graphed it and did all that, that's okay, but I'm not worried about that. Just switching. So the new x values, new domain is 1, 3, 5, and 5. And the new range, the new y values are -1, 2, 3, and 5. Just switching. 21. F inverse is x plus 1 3/4. might be x plus 7 all over 4. You had 24, the last one, is 0.08x minus 11.6. But that wasn't the last one, 27 was, wasn't it? 27 was f inverse of x is negative 3x plus 6. Again, basically switching x and y, solving for y. Any of those you want me to go over? Why don't we look at 24? Because it would have a decimal in it. Okay, so y equals 145 plus 12.5x. Again, they had f of x, but we're thinking that's y equals, right, Nicole?
Yeah.
So all I'm doing is making x equals 145 plus 12.5 y. So where am I going to move first, Kate?
I don't know. 24.
I want to get y by itself. Where am I going to move first?
Subtract 145.
Yeah, just subtract 145. We all know that, right, Trent? Again, it's nothing new. You guys learn this in Algebra 1, how to solve for a variable. What do I do with that 12.5? Divide. Dan? Okay, thanks. Okay, so if you left it like that, that's okay. All right, if you divide it out, it's 1 divided by 12.5. Oh, I have it in a graph. 1 divided by 12.5. 0.08. So that's where that came from. And then 145 divided by 12.5. That's the 11.6. Okay? Either one is acceptable. Is that section that difficult for you guys? That's pretty easy, isn't it? Okay? That's a pretty easy section. All right, today's something that you've never done in your life. So focus. Okay? We're going to talk about logarithmic functions. You've never done logarithms before. Yeah. So, we talked about exponential ones. What was that, last week, right? That was what we did last Thursday and Friday. How did we know it was an exponential equation or function? Variable was our exponent, right? Okay, so what we're going to do is we're going to write exponential functions as logarithmic and logarithmic as exponential. That's what you have to learn today. So focus. It's really not that hard. Okay? So logarithm, we'll talk about common logarithms and what a logarithmic function is. So how many times would you have to double a dollar before you had $8? You could use an exponential equation to model this. We start with a dollar, and then we're doubling it each time, right? So our base is 2, our exponent is x, to get 8, all right? You may be able to solve this equation by using mental math if you know 2 to the third is 8. So you would have to double the dollar 3 times to have $8. All right, so we got a dollar, I double it the first time, $2. Second time, $4. Third time, $8, right? Says, how many times would you have to double the dollar before you had $512? You could solve this problem if you could solve 2 to what power equals 512 by using an inverse operation that undoes raising a base to an exponent equation to model this situation. This operation is called finding the logarithm, right? So the logarithm is what? The exponent, okay? So the logarithm, whatever that exponent is, when you have a base of 2 in this problem, okay? So here's what they look like. Here's my exponential. We have a certain number, base, raised to the x power equals some number. Like 2 to the third equals 8, right? 2 is the base, 3 is the exponent. Our number is 8, okay? Now, our base has to be what type of number? What's that telling you? Which means what type of number? Yeah, what else? Positive, yeah, right? Numbers bigger than 0 are positive numbers, right? So our bases will be positive, and our base will never be 1, because 1 to any power is what? 1, right? So we'll never have 1 as a base, okay? So this, the way you read this is log base b of a equals x, okay? So whatever the base is over here is this little, we call it a subscript, a little number, a little below right of the g after log, okay? So if I had, if I had 2, let's just do it this way, we'll keep the same colors. So if I had my base green like they do, to the third power equals 8. We just talked about that, right? We all know that. 2 times 2 times 2 is 8, right? That means we could write log base 2 of 8 equals 3. You should be able to look at this exponential equation. Cool. Come back to me. You should be able to write this exponential equation as this logarithmic equation. You should be able to write this logarithmic equation as this exponential. You need to go both ways. Okay? So again, this is log base 2 of 8 equals 3. That means 2 to the third power equals 8. Simple. Questions so far? No questions? Okay, so let's practice. Olivia Wyndham. This says 3 to the 5th equals 243. So put it in logarithmic form.
Okay. So it's gonna be log, and then, 3. So
Base
log-
3,
and then-
good, of,
Okay, 243.
good, equals,
5, is that a 5?
that is a 5, yes, very good. Kind of hard to see that 3 from where you guys are. But she's right. 3 is the base in the exponential problem, so it's log base 3, whatever it equals of the number equals the exponent. Remember, the logs are the exponent. The log always equals the exponent. Mr. Zito, this is not in the right spot. This 1/2 should be with the 25. But I don't know why it does that to me. Every year it does it to me. I fixed it and it's still. Come on. Anyway, maybe I'll just get rid of that one. So that says 25 to the 1/2 power equals 5. So what's the base?
25.
Right, so log base 25 of 5 equals 1/2, the exponent. Danny,
Log to 10.
log base 10,
Base 10. 10,000.
good. Sydney,
Log base 6, 1/6 equals -1.
good. Zach,
Log A base C B.
right, so the way we say it, log base A of C equals B. Questions so far? Evan? Go ahead.
Base or log base 9 of 81/2.
Good. Andrew?
Log base 3, 27 is equal to 3.
Good. Grace?
Log base X is
Of?
1.
Yes.
Do I add that other stuff?
No, don't worry about
Okay. Equals 0.
that. Right. They're just telling you the base can't be what? 0, right? It's gotta be a positive number, right? All right, we good so far? Okay, Scott, you ready? Got this? Going the other way. What's the base?
9.
What's the exponent? Equals. Very good. 9 to the first equals 9. Olivia Carr.
2 to the 504. 2 to the 9 to the 500.
There you go.
Sorry about that.
2 to the 9. John. I'm going over there.
It's in the second.
Close.
It's in the third.
Yeah, 8 to the third equals.
1/2.
No, what number is there?
2.
2. 8 to the 1/3 is 2. Kolak.
Yeah. Oh, yeah, well, that's all fine.
Come on, this is easy.
Alright.
What's the base?
4.
Yeah. What's the exponent? Remember the log equals the exponent. So what's the exponent? Yeah. Equals what? Yeah. 4, again, all it is, that's the base, that's the exponent. So 2 to the 9th, 512. 8 to the 1/3, 2. 4 to the negative 2, 116. Simple. Cole-Everly, that's a B.
Oh, that's a B?
Yeah, so you're right. You were thinking right.
B to the 0 power?
Yep.
Equals 1.
Right, and anything to the 0 power equals what?
1.
1, right? We already knew that, didn't we? Yeah, we knew that. Kennedy,
There's the same way, 10 to 1 to 1 equals 10.
good. Grant,
12 to the second equals 144.
all right, you guys knew that. 12 squared is 144, right?
Yeah.
Alex, this is in the wrong spot again. These fractions always mess up.
There's the whole equation there.
Oh, hey, that's a good idea, because that worked before, didn't it? Who told me that? Trent.
Who else is?
I don't know, but you didn't get dropped on your head at practice. Oh, that's right, you weren't there. So that's pretty good job. All right, who was I getting? Alex? No. Base is at 1, a little below. 1/2, yeah, 1/2. To the, can you see better if you look to your left? I don't know. Yeah, 1/2 to the negative 3 equals 8, yeah. All right? Do we understand that?
Yeah.
Any questions? You have to know that before you leave today. Okay? Grace?
Why is the last one?
Just because it's a fraction, I guess. It doesn't have to be. All right, some properties. If the base and the number are the same, what's the answer going to be? 1. Okay? If it's, no matter what the base is, if it's a 1 right next to it, the answer is always what? 0. Okay? No matter what the base is, log base anything of 1 is always going to be 0. Okay? Again, usually what I do is I rewrite it. If I have to solve a log problem, I write it exponentially and I can figure it out. If I have an exponential one and I'm trying to figure it out, I usually write it as a log and I can figure it out. It's going the other way. It usually makes it easier. A logarithm with base 10 is called a common log. That's the one on your calculator right here. They won't, if you don't see a number, little number to the bottom right, after log, it's one of these. It's a common log. It's a base 10 log. Okay? So this was log 5. They didn't put the number. You're supposed to know it's 10. Okay? That's one you can just put in your calculator. All right? So what's the base? 10, right? Now they want us to do without a calculator. All right? So let me show you. So this is 10 to, here's what I do too. Sorry, I forgot my little step. I always write this to start, these. So what's the base that we don't see? 10. What's the exponent? No. S equals the number, right? What if I wrote it like that? Isn't that what 0.01 is?
Wait, where did you get one?
If there's no number written, right here, the little, that's a common, that's base 10, yeah. Okay? So, again, you can just put that in your calculator because it's a normal common log, all right? But they asked us not to use the calculator, right? So, How can I write 100 with that base?
You could do one and then just do 1/10. Right?
Well, if it was a 10, it'd be 1/10, but it's 100, so it's 1/10 squared. So when the exponent's in the bottom and we want to put it up top, what happens to it? What happens to that exponent if I move it from the bottom to the top? It becomes negative, yeah. That's the answer to that, -2. Okay? Equals x. So what's the exponential problem? 5 to the x equals. So what exponent of 5 gives you 125? 3, right? 5 times 5 is 25 times 5. 5 quarters is $1.25, right? Okay. Remember, when you have a problem like this, just write equals x. So what's the exponential problem?
5 to the x power, this will be 3.
All right? And I could put that like that, right? So what's the exponent going to do to get that from down there to up there? Becomes negative. So that's 5 to the -1. So the answer is -1. What's the base? 10, right? So 10 to the x equals 1/10 to the what? 1, 2, 3, 4, 5. So what's the answer? What's the answer for x? -5. You guys are getting it. Good job.
Alright.
What's the base?
25.
25, right? So the x power equals, what's that? How do you say that properly? 400, right? Which is what? What's that reduced to? What's 400 reduced to? 1/25, isn't it? What's the answer? Nope. What's the exponent going to be to make that work? Louder. -1. Very good.
Oh, God.
Start doing it again.
Okay, I will.
I didn't want to stab you.
Oh, my.
Well, I'm not stabbing you. Actually, guys, give me one.
Oh, I know. It's so nice.
So many.